This video will teach you how to identify whether two lines are parallel and perpendicular. So first, let's make sure we understand what parallel and perpendicular lines are. So they have a special relationship in that parallel lines, if they kept going and going and going and going, they would never cross. They don't ever intersect. Whereas perpendicular lines are going to cross, but not only are they going to cross, they are going to form a 90-degree angle. They're going to form 4 of them. So there's 1, there's 2, and if this kept going here, that would be 3, and that would be 4. It would create 4 90-degree angles. Okay, so it's really easy for me to remember the difference between the two of them, because if you look at the word parallel, it has 2 parallel lines within the word. So parallel again means they don't ever intersect, whereas perpendicular means they make a right 90-degree angle. So here's some real life examples of parallel lines. So if we look at the lines on a football field, those are parallel. If we look at railroad tracks, we know that this line and this line here, they are parallel, they're side by side. Now, it may look like they meet back here, but that's just because it's in the distance back here. But we know railroad tracks, there's no way. They have to be parallel. These are parallel, because if they don't, then they're going to intersect, and that would not be good. So parallel lines are on railroad tracks, okay, as well as on the field. If people are, running in a race here, these lines have to be parallel so that they run and they do not run into each other, just like parallel lines on a road. And then this would resemble perpendicular lines, like when we make doors, or like right here when we're putting like a board here, that this would make a 90-degree right angle right here. So that would be some real life examples of perpendicular lines. So now when we want to make parallel and perpendicular lines, think about it for a second. If we want two lines to be parallel, they have to be going in the same direction. So from the left to the right, if this is a positive slope, then this one also has to go in the same direction. Because if it didn't, and we had one positive and one negative, then they would crash. They would intersect if one slope was negative and one was positive. So for us to have parallel lines, and parallel lines never intersect, the slopes have to be equal. They have to be the same. Whereas for perpendicular lines, in order to have perpendicular lines, they can't be the same, because perpendicular lines intersect. Now, again, notice these two lines here, they intersect, but they are not perpendicular. This is not a 90-degree angle right here. This is not a 90-degree angle. So perpendicular means they intersect, but when they intersect at the perfect right angle that this is going to be 90 degrees. And so what will cause that relationship there of that 90-degree angle is if the slopes are what we call a negative reciprocal in relationship. So negative reciprocal. So what are negative reciprocals? So we should know coming into this class what a reciprocal is. So like, for example, negative 4/5. The reciprocal is if we flip these two numbers over, that would be 5/4. And if this is negative, then this one's going to be positive. That's what the negative reciprocal is. Like, they're negating. So one is negative, and then the other one is opposite, is positive. So that's what negative reciprocals are. So if we look at this example here, if we have 3, and 3 is the same thing as 3/1, and we go and flip it around, then the 1 would come up top and the 3 would go here. Now if this is positive, this one's going to be negative. Okay, so let's just do a few more just to make sure we understand. So if we're asked for the reciprocal of 2, we're going to go ahead and take 2 and flip it around, so the 2 will come to the denominator, and since 2 divided by 1 is 2, we'd have 1/2. Now, so that's what a reciprocal is. But because it says a negative reciprocal, one of them has to be negative. So since this one was positive, this is going to be negative. Okay, so if we take a look at the second one here, if we had negative 1/4, and we want to find the reciprocal, we would flip them, which 4 over 1 is just 4. And since this one is negative, then this one's just going to be positive. And that is what we call negative reciprocals. One of them has to be negative, one of them has to be positive. Okay, so let's take a look at 3/4. So if we want the reciprocal, we just switch them. And since this one here is positive, then this one would be negative. And if we take a look at the last one, if we flip 1 over 1, it's just going to be 1. And since this one's negative, this one would be positive 1. So again, that's what it means to be negative reciprocals. Okay, so let's take a look at example 12. Now, let's pretend this graph right here was not there. So ignore it for right now. Let's focus on the equations. So we're asked whether if we were to graph these two equations, what type of lines would they make? So the reason why I said to ignore this picture is because we should know that they are going to be parallel because the slopes are the same. And since they're the same, we know they will make parallel lines. And again, super easy for us to remember that because the word parallel has 2 L's, and the L's are the same, and they're parallel, so that just helps us remember. So if we take a look at this equation right here, if I pick 2 points right here, and I go rise 2 and over 3, rise 2 over 3, you could see that this line right here has a slope of 2/3, and then same thing over here. So if we rise 2 and go over 3, rise 2, go over 3, these two lines both have a slope of 2/3, and they will never intersect at all because the slopes are the same. Now if we take a look at this example here, again, ignore the picture, pretend like it wasn't there. You would look in front of the x, and we have a 1/2 in front of this one. And if we flip it, we would have 2 over 1, which is just 2. And since this is positive, we need this one to be negative. And if we look at this equation right here, you will notice there's a -2 in front. So therefore, we would know that the equations are perpendicular because the slopes are negative reciprocals. One is positive and one is negative, and they're reciprocals of each other. Now, if we take a look at this line right here, and we pick 2 points, and we rise over run, that has a slope of -2 because it's going down. So there's that one. And then this equation here, if I pick 2 points, rise 1 over 2, that's this one right here. So we have 1/2 and we have a slope of -2. And as you can see, when they cross each other here, they make a right angle. And what causes that is this relationship that these are reciprocals, negative reciprocals. All right, so this time we don't have a picture to look at. So go ahead and identify whether the lines are parallel, perpendicular, and either. So hopefully you're thinking, well, this slope is 3. And then if we look at this slope, it's -3. So they aren't equal. So they're not parallel. And perpendicular would be if we flip this, which that's not the case. They're not reciprocals of each other. So This one is an example of neither. It's not going to be parallel. They are going to intersect, and they're not perpendicular. So these two lines here, if we graph them, they're going to intersect, but they're not going to be parallel and they're not going to be perpendicular. Okay, if we take a look at this example here we have negative 2/3. And if we look at this equation here, that one is a 3, so they're not the same, so they can't be parallel. And perpendicular, if we flip these two here, and if this one's negative, this one's positive, if we look here, that is not the slope of that one. So therefore, it's not perpendicular, and it would be neither. Let's go ahead and try a couple others for extra practice here. So we're given this equation, y equals 3x minus 5. So we look in front of the x, and that is the m, that is the slope. And we want to know which equation would be perpendicular to y equals 3x minus 5. So if we take the 3 and flip it, we would have 1/3. And because this is positive, this one has to be negative. So we need to look for which equation has a slope, the number in front of the x, the coefficient of the x, needs to be negative 1/3. This number here does not matter. These numbers don't matter. What we're focusing on here is the slope, and we need a slope of negative 1/3. So that would be choice D. So if we were to graph this equation here and this equation here, they would be perpendicular lines. They would form a right angle. Okay, here we're asked to identify whether these two equations are parallel, perpendicular, or neither. So if we look in front of the x, we have a 4/5, and here we have 5/4. And they're reciprocals, but they're not one of them is not negative. And because one of them is not negative, they're both going to go up. And since they're both going to go up, we know that they're not parallel, they're not the same, so we know they're not parallel. And they are not going to be perpendicular lines because they are not negative reciprocals, so we're going to have neither. Okay, then we're asked, are these two lines parallel? So to find the slope, we have to look in front of the x, but it has to be in y equals mx plus b form. So neither of these lines are in y equals mx plus b form, so let's practice that skill. Let's go ahead and get the y by itself. So we're going to subtract x. And then we're going to divide by -2. And we get y equals a negative divided by a positive. Okay, now we're going to do the same thing over here. So we're going to get the y by itself. So we're going to subtract 2x. Then we're going to divide everything by -4. We get y equals, we have a negative divided by a negative is a positive. 2/4 is the same thing as 1/2. And then here we have a positive 8 divided by a -4, and that is -2. Okay, so now that we have the two equations, if we look in front of the x, we can now see they are the same. Again, this number does not matter. This number does not matter. But because the number in front of the x is the same for both of them, then we know that yes, the lines are parallel.